Okay, so just a quick overview, okay? First of all, for any equation, you should be able to do a direction field and apply the Euler method, okay? So you need to make sure you can do that. This is easy, okay? Now, analyzing the quality of your solution and stuff like that, that's a little harder. We're gonna talk about that in the second half of the course.
Okay.
Okay? But right now, just be able to do them. And if you can have some insights on how accurate your solution might be, you at least ought to know if you use a smaller increment, you tend to get a better solution with the Euler method. And the more little lines you draw in a direction field, the easier it is to follow them and get a reasonably accurate solution. But the geometric picture, so you gotta know that, okay? Because that can work for any equation. Of course, this all gives you insight into the fact that if you got a place, like for a certain value of x, the thing is undefined, your solution can't cross that corresponding vertical line, right? Stuff like that. Okay, so you have that. Now, what kinds of equations do you have? Generally, the first kind of equation we really look at is first order homogeneous. Okay? We saw this quite a while ago. You know, that's, for example, y prime plus p of t y equals 0. Right? And your solution is y equals a e to the negative capital P of t where capital P prime equals little p, right? And then we have y prime. Okay, well, if it's non-homogeneous, first order non-homogeneous, we got y prime plus p of ty equals q of t, and then the integrating factor e to the capital P of t leads to this form, okay? Or pick capital P of t is the same as when, you know, it has this relationship to your little p of t, okay? It's first order, linear, homogeneous, not homogeneous. If it's separable, it's like you've got y prime equals f of t g of y. We can separate it into a product of a function of t and a function of y. So you get dy over g of y equals f of t dt. You integrate both sides with your integration constant and so forth. You know how to handle. Okay, so not going through the algebra of that. So you have this. Okay? So, Now, before we go too far, we'll talk about the Bernoulli equation, okay?
Okay.
Okay. Y prime plus P of Ty equals Q of Ty to the n. And change variable to V equals Y to the m. Becomes linear and non-homogeneous. Okay? And you gotta be able to do that change of variable. And ideally, derive y m equals 1 minus n. Okay? Okay, so what else do we have? We have logistic. Equation, which is basically a lot of ways it can be written, but it's like y prime equals various ways it can be written. Okay, well, let's little background, just to clarify it. Okay, if you have y prime equals ky, okay, we have this, right? So now you're going to have y prime equals not ky, okay? But it's going to be like I don't know if I want my parenthesis there, but I'm going to do it anyway. L minus y times y is one way to write it. Now your book is going to use different notation. Okay? And actually K might not be the best thing to use here, but what you see is the rate of change here, okay, decreases as y approaches L. Okay? So it's of this form.
Okay.
Okay? And that leads to a solution. And what you get is you get a solution that kind of grows exponentially, kind of like a k, you know, y prime equals ky. But then as you approach a limiting population, it levels off. And if you start from above, it'll exponentially decrease for a time, but it's going to approach from this side. Okay? And you got to use partial fractions and stuff to solve this. Okay? And you know the techniques, they're fairly straightforward. So I'm not going to go over the techniques, but you got to be able to identify the equation. Okay?
Okay.
So it's like the population of guppies in a tank, which is
Yeah.
what we use. Okay? You got some limiting value of the population, it doesn't really matter when you're down here, because you got all the food and space you need. We grow exponentially, but as we approach the limiting population where you don't have enough space, can't get enough food, cannibalistic little critters eat each other. Well, they eat the young, the adults don't bother each other, okay? But it gets harder and harder for an egg to hatch and grow to maturity. And then that's the main thing that limits your population, so you must start approaching here. And if you start with too many guppies, well, even though you know, practically none of the little ones hatch and reach adulthood, they get eaten almost immediately. But also, they get eaten really quick because everybody's really hungry. There's not enough food, not enough space, and maybe they do start attacking each other. I've not observed that. Okay? But population will come down to whatever the limiting population is.
Yeah.
Okay? And the solution to the equation is sort of straightforward. It's a separable equation. Okay, you get well, dy over L minus y equals dt, or k dt, okay? You got to use partial fractions to integrate that. So you're going to end up with a natural log of y and a natural log of L minus y. One will be negative, one will be positive, and then you just do the algebra to get a solution, okay? And you should recognize what the solution looks like so you know if you got one.
Okay.
Okay? Okay, well, out of space here, but we'll go on in a minute.